Alright, Alan here. A little update on the project to replace the brushless linear DC motor and drive system on my Mikini Mechatronics 1610L milling machine with a AC inverter duty motor, 2 horsepower motor, and sensorless Hitachi sensorless vector drive. So it's been a while since I posted a video. Apologies for that. I've just been really busy, both with work and with actually the mill. It's not that I haven't been working on the mill. I have been working on the mill, but I was a bit stymied with one part of the project that actually took a good week to sort out. And what that was the home switches. I replaced all the home switches with some Honeywell switches that are TTL logic level, meaning plus 5 volts and 0 volts, so that they would work with the new C23 breakout board. And so I had to replace all the homing switches with the new Honeywell ones. I replaced the Z. That was really very easy. And I replaced the Y, and that was no problem either. It's actually up underneath here. The Z is actually, well, you can't see it because the way cover's on, but it's up at the top behind the way cover. And they're just photo interrupter switches, and the existing flags that were already in place, the metal metal pieces that would block the photo interrupter switch, worked fine on those two. On the X-axis, not so easy. The switch was up underneath the table on the back side, and the flag is somewhere in the middle. And when I put the switch on the X-axis, for some reason the new one was running into the flag and getting crushed by the flag. So I actually crushed 2 photo interrupter switches, and I wasn't really sure what to do because I can't really get to the flag to adjust it or anything like that because it's way up in the middle of the table. So what I finally decided to do was relocate the X switch to up underneath here. You can kind of see it up underneath there. That's the switch there, and then I've added a flag right there. There's the flag. This is much more accessible, much easier to get to, and a heck of a lot easier to work on. I mean, to even see the other switch on the back side, you practically had to turn your head upside down underneath the table. It just wasn't accessible at all. So this is probably going to be a little bit more exposed to coolant and such, but I don't really think it's a big deal. It's still pretty protected up underneath that shield. So little modification there, and took way longer than I ever thought it would to do the homing switches. I thought that was going to be easy, and it turned out to be a real pain in the butt. But on the plus side, it does home now, and I'll show you here in a second. It's actually moving now. It's a lot quieter. The steppers are a lot quieter with the new Kelling digital drivers that I put on. I put those with the new electronics, and not only did that make the wiring a little bit easier, the mid-band resonance is all but gone from the stepper motors. So you can see it's moving at about 20% there. And usually, you know, when you run steppers in the middle of their frequency band, they get a lot of resonance going on. But not with these digital drivers. That's the one thing I've noticed about them. Is it just seems like they're a lot smoother in the middle part of the frequency band there. So that's it. It's homed. So not a big deal really, but you'd be surprised how happy I was to have the machine home properly after all the trouble I went through. So you probably hear that fan, the fan that just shut off. That's actually the the Hitachi VFD. It's wired up, and so basically it goes, so there's the power supply down there. It goes through that back panel there, and eventually I'm going to wire it, or not wire it, but mount it rather, right here on the inside here, the VFD and the fusible disconnect. So that's a fusible motor disconnect, separate for the VFD, 30 amp if I remember correctly, and then of course the VFD, and the motor's wired up, and it turns the motor. So that's progress. I'll show you that in a second. So the wiring, which isn't totally done yet, it's still in process. So this is a bit of a mess and kind of hard to show, but let's see. That's the C23 board there, obviously 12-volt power supply. Right now I'm running 5 volt off of it's like a USB power supply. I'm going to replace that with a 5 volt Kelling power supply. Smooth stepper down on the bottom. Let's see. Those are the digital drivers from Kelling. They are the big ones. I forget what they're called, but they're like the 80 volt, the largest ones that they had on the digital driver. That's the old Mikini CNC power supply. It's basically a rectifier, I believe, that's receiving, I think it's receiving 230 volt single phase and spitting out DC voltage at about 70 volts. And that's the wiring going into the C11, or C23 rather. Nice feature on the C23 is you've got those little diagnostic LEDs for each input and output that shows their status, kind of like the input and output status inside Mach 3 itself. You've also got the LEDs on the board. So the next step, I've got 12 volts going to the motor, the analog motor controller. The next step is going to be to wire that up to the VFD so that Mach 3 can control the VFD via analog motor control. And then those blue things right there are the relays. There are two 8 amp relays that come included on the C23 board. And one of those is going to get wired up for the flood coolant. So yeah, kind of a mess, but it's all working for the most part. So let's check out the Hitachi. I'll crank her up here. So I know a lot of you were keen to check out the Hitachi under power and actually see it turn the spindle, and we're at least to that point. Not quite to the point where Mach 3 is controlling it yet, but we're gonna get there real soon. So yeah, so far so good. And I'll run it up and down through some of the frequencies here. First I'll slow it down. Should probably bust out my RPM, my tachometer or whatever, and see what the RPM is on this guy. Haven't done that yet. At the lower frequencies, you start to hear like a frequency artifact, I guess. But it smooths out once you bump it up. I haven't cranked it all the way up yet. Kind of a little chicken to do it, just in case something flies apart. Shouldn't, but you never know. Let me shut this just in case. It's still not all the way up, but you can sure hear that fan going. Okay, that's full speed there, 120 hertz. Should be about, I forget, I think it's like 5,200 RPM or 5,500, something like that. If my math is right. So, all that noise is just the fan on the top of the AC motor. And then we're back to base frequency more or less. So, I guess it didn't fall apart or anything, that's good. Only thing I'm kind of worried about is my interference fit on the timing pulley. I mean, I think it's good, and I'm quite sure it's good actually, but you know, you hate to find out the hard way that you made a mistake. So, yeah, that's it for progress. I'm thinking I'm making a lot more progress now that I got past that home switch issue. That really held me up far more than it should have, I think. But now that I'm past that, you know, the next step is obviously to wire the terminals on the VFD to the C23 analog motor control and get the VFD under Mach control. And yeah, and then you know, lots more to do. Obviously, wire up the flood coolant through the relay, clean up some of the wiring, get the lamp working, do the front control panel, get the pendant, the new pendant wired up, get a new e-stop up here, a couple new power switches probably, just tons of stuff to do. But I should be at a point where I can make chips again pretty soon here, actually. Once I get the flood coolant and the VFD talking to the C23, I'll be good enough to make chips again. So yeah, that's about it for now. More later. Thanks for watching.